So just a quick tutorial on how to do regression from a photograph in Geogebra. Um, I've just looked at an example in my office where I have a phone wire hanging from the wall. So I'm just going to copy that image. I've cropped it so the corner of the picture is the start of the curve. I can just paste that into Geogebra. And I'll just show you the steps here because it can be a little tricky to get this right. So just place the image so that your curve starts at the origin. Once you've placed the picture, you can right click the image, go into settings and make it a background image. After you've clicked background image, you won't be able to move the object again. So make sure it's in the right position. Once that's done, we can start plotting points. And we use the point plotting tool at the top here, so just the first option, point. And we start marking off points on the curve. And we don't need that many. It's usually enough with 3 points for a parabola like this. And there you have it. We have 5 points. Mind you, points A and B are used to mark the boundaries for the picture. So they're not part of our regression. So we want points C, D, E, F, and G. Now comes the tricky part. We have to make a list of these points. So we can define a list by giving it a name, for L, for example, and then an equal sign. And to get the right type of bracket, you have to press the Alt GR button next to your space button and 7. So these are the brackets that you found on the 7 and the 0 key. And I'll just enter the points C, D, E, F, and G. And capitalization will be important here, I think. And once you've done that, you can just press enter, and there you have a list of points. That's the list. Now, in English, you have to type in fit at the beginning. In the Norwegian version of Geogebra, I think the formula starts with reg, so reg poly, so reg is for regression. But here it's also called the line of best fit or the curve of best fit. So in English it starts with fit. So we want to choose fit polynomial. So this is the polynomial function. That's what this is going to be, or a polynomial model for a function. And we have a list of points, and we have the degree of polynomial will be 2, because this is going to be a quadratic equation. The list of points, we could type in the points here, but we can also refer to the list that we've made, which is called L. Sorry, that's capital L. And the degree of our polynomial is 2, because this is a parabola quadratic equation. And I just press enter, and there I have my curve. And you can see that this curve fits quite nicely with the points that I've plotted. And here we have the equation for that curve. So 0.17x squared minus 2.29x minus 1. And that's how you can model real-life phenomena from a picture in Geogebra.